All right, so we are looking at 19 through 24. First of all, it just says to evaluate without using a calculator. So the tangent of pi over 4. Okay, so with these, for now, you're just looking at your unit circle and we're putting the values down. Okay, obviously for like the quiz, the test, you're gonna not have the unit circle in front of you except for if you fill one in. So I would recommend you start learning it. I mean, we're not gonna have a regular quiz before your unit circle quiz. Okay, so obviously you don't have to worry about that because you should know the unit circle by the time you have a quiz. But then it's easy extra credit. Anyways, what is the tangent of pi over 4 from the unit circle? Okay, 1. Sounds pretty easy. Okay, a little harder though. Secant of pi over 3. Okay, so this involves understanding how to use the unit circle and understanding how your trig functions go together. So what does secant go with?
1 over sine.
Okay, it's 1 over cosine. So you're going to look at your cosine of pi over 3. Okay, so we're going to look at 1 over the cosine of pi over 3. Okay, the cosine of pi over 3 is 1/2, so 1 over 1/2, which is just going to be 2. Okay, now, you don't have to show all of these steps. Okay, my assumption is you have a unit circle in front of you. You understand where it's coming from. The only step that you may want to show, really, to make sure that if you do something wrong, I can see what you did, okay? Because like a lot of you said it was 1 over sine. So if you had shown me that, then I would have realized, okay, you just got your functions mixed up. Not like you just can't multiply or divide.
So in the unit circle, cosine is always x and then sine is always y.
Yeah, I probably should actually put that in here. Yeah, cosine is x, sine is y on the unit circle. Let's see, 24. Cosecant of pi over 3. Book likes pi over 3, that's for sure. So what would the cosecant of pi over 3 be?
That'd be 2 after 3 over 3.
Yep. So it's 1 over the sine of pi over 3, which is 1 over the sine of pi over 3 is root 3 over 2. And then, like you said, it would be 2 root 3 over 3. Okay, your book does the same thing. This is what I want you to write your answer as. The book does it this way. They write it as 2 over root 3. It's not good math to leave it that way. Don't do it that way. Okay, do it like this, like we would normally rationalize them. Okay, just like some other examples really quick. Okay, just because they only do stuff out of that quadrant with these ones. The sine of 90 is what?
1.
Okay, 1. Okay, that's good enough for now with those. 25 through 28 says to evaluate using a calculator. I don't know why it says to use a calculator because the answers they give are not calculator answers. They give the answers are like straight off the unit circle, which makes more sense. So don't use a calculator for them. Just be able to do them. Okay, so 26 is the sine of 60 degrees.
Root 3 over 2.
Okay, root 3 over 2. 28 is the tangent of pi over 3.
Root 3.
Root 3. Okay, so that's like if they give you the cosine of an angle or the sine of an angle, whatever, you're finding what the xy value is. Okay, but 41 through 48 does the reverse. It tells you that like the sine of theta is equal to, and then it gives you one of the y values on the chart, and you have to tell which one it is. Okay, and it wants specifically the acute angle theta. Okay, meaning it wants one of them out of quadrant 1. Okay, because obviously if you look at the unit circle, okay, there are obviously every, like if I were to tell you that I want the sine of theta being equal to root 3 over 2, that happens in 2 places on the unit circle. Okay, if you look at it, the sine being root 3 over 2 happens in 2 places. Okay, so when it says acute, we want everything that happens in this first quadrant right here. Okay. Now, if it does not specify that it wants the acute one, you write both. Okay. So 42. Oh, look at that. Sine of theta is equal to root 3 over 2. I didn't even know that was what the problem was. So, and it wants you to give it in both degrees and radians. Okay, so this would be 60 degrees and pi over 3 radians, okay, or just pi over 3. 44 cosine of theta
Wait a minute, you can just convert this.
is equal to root 2 over 2.
Oh, it's stupid. I'm so dumb. Oh, that's like
45.
yes.
Pi over 4.
45 degrees, pi over 4.
Because if you take 45 and divide and then do like the conversion thing, you can check the alternatives.
46 cotangent of theta is equal to 1. Okay, so the cotangent ones, we haven't seen one of those yet in either type of the problem that we've been doing. At least I don't think we did one. Okay, so you have to remember we don't have cotangent written down, and you have to reverse it. Okay, cotangent is x over y. Okay, so this one, it being 1, should be easy because that would mean the tangent and the cotangent values are the same in both places. The issue is when you get to do the ones that are like the pi over 3s and the pi over 6s, okay, the cotangents are reversed. Okay?
Okay, cotangent is x over y.
Yes, cotangent is x over y. Okay, so where is the cotangent 1? That's acute.
45 degrees.
Okay. 45 degrees or pi over 4. And then lastly, and we'll do the last bit of this exercise in this section tomorrow. 48 cosine of theta is equal to root 3 over 2.
That's the x value, so that's
30 degrees, pi over 6. You know what, there's actually only a little bit left in this section that we need to do, so let's just go ahead and wrap it up, and then that way we're just done. Alright, so then these ones just say to solve for the variable shown. Okay, so 50, we've got a triangle. The bottom is 23. The hypotenuse is z, and we're told it's 39 degrees. Okay, so I want to solve for z. Any ideas on what function to use for that?
well, you could use the tangent.
Tangent's not going to help me. I need something that's adjacent and a hypotenuse. Cosine.
Always
Okay. So the cosine of 39 is equal to adjacent over hypotenuse, so 23 over z. Okay, then I can just flip the z in the cosine of 39. So again, this is where you need to make sure your calculator's in the right mode. Make sure you check that. So z is equal to 23 over the cosine of 39. Somebody tell me what that's equal to.
It's like 73.5.
How much?
25.59.
25.59.
There's no way it's 25.
It's 29.59.
Oh, yeah, 29.5.
Thank God. I was like, I wasn't that far off. It's like, the original answer was 30, I changed it to 33.
Okay,
That's
54.
not bad.
That was technically a right triangle. You need to know that. Actually, no, it wasn't. This one is a right triangle, though. Oh, I'm still on the eraser. There we go. Okay. All right, so this angle up here, 66 degrees. Got a side length of x and a hypotenuse of 50.
Well, that's gonna be the sine. I mean, the cosine.
Okay, cosine of 66 is equal to x over 50. Okay, so then x is equal to 50 cosine of 66, which is what?
It's gonna be like, what numbers are calculated in degrees for this?
Degrees.
It's gonna be like 30 again. That's all.
Yeah.
Because
20.34.
it's either 30 or 20. That's it.
Okay, 20.34.
Yeah,
I'll be like, imagine if you could do this for.
Okay, and then two more and we'll be done. 56. Okay, actually here. For these ones, it gives us a triangle to go off of for both of these problems. Okay, so this angle here is alpha, beta, and then we have our right angle. Okay, and then the side lengths match up with them.
Is this for 56?
Yeah, for 56 and 58. Okay, so for 56, we're told that alpha is equal to 41 degrees and that side C is 10. Okay, so I'm going to draw the triangle again with stuff filled in that we know. Okay, so alpha is 41 degrees. And then obviously we know that C is 90 degrees. Okay, side C is 10. Okay, so I need to find all the pieces. Okay, so when you write your answers, I want all your angles. Okay, your angles are capital letters, your sides are little letters. Okay, so angle A was given to us. It was the alpha value, so that is 41 degrees. We know C is 90 degrees because it's a right triangle.
So it's gonna be 49 degrees.
Okay, 49 degrees for B. Okay, you do 180 minus all of those values. So minus 90 minus 41 is 49 degrees. Okay, I know side C is 10. And now I need to find side A and side B. So how would I do that?
What, you'd find the sine. Go,
Yeah,
let's
the sine.
find A, so take the sine of 41 times 10.
Okay, so the sine of 41 is equal to A over 10. So A is equal to 10 sine of 41, which is what? Okay, for all these, your calculator stays in degree mode.
6.57.
6.56. And then for B, okay, for B, you have a couple options. You can either do the Pythagorean theorem, which I would not recommend doing just because it's going to cause more work for you, in my opinion. I would just use like the cosine of 41 again. Okay, you can also use obviously the other angle that we started with. Okay, but the cosine of 41 would be equal to b over 10. Okay, I would say don't use something like tangent just because you're going on a rounded a value, and if your a happened to be wrong, then your tangent is like also going to give you a wrong answer. So I would go with the stuff that we knew from the start. So using like 10 cosine of 41. So b is equal to 10 cosine of 41, which is equal to what? 7.55. Okay, do y'all feel like you need to see another one, or are you good? Everybody's good? Alright, so then the problem's being added on 19 through 27 odd. Okay, the only reason you're getting all the odds is just because you're reading off the unit circle, so it should go quickly. Okay, whoa. What is happening? Okay, well, apparently the pencil just died on me, so then the other ones are 41 through 47 odd. Okay, again, those are just reading off the unit circle. And then as far as the other ones, 49, 53, and
This is 4.2.
57. Yes, all from 4.2.
Maybe in the future
Or just
we'll
do-
have pencil fingers.
Huh?
Maybe in the future we'll have pencil fingers.
What?
What does this do?
Tomorrow. But you still have time. You should literally, the only ones that should take you any amount of time are 49, 53, and 57. The other ones are literally just reading them off the unit circle, so.